Okay, right now we're going to determine how to find the domain of a function. And remember, the domain are the inputs, the possible x values, and we want to know what is the entire set of x values, numbers that could be substituted in for the x in an equation, and after evaluation, still result in a real number, not give us an undefined situation of any kind. That's what we're going to do here. So in this first equation, we kind of look at each of the operations. We're squaring, adding, and we're subtracting. Okay? None of those operations result in an undefined situation when dealing with real numbers. In other words, any real number that we want can be squared. Any two real numbers can be added, and we can certainly subtract 5 from any real number and still be in the set of real numbers, still get a fine number. Nothing's going to go wrong, nothing's going to be undefined when evaluating numbers in this function. So for that reason, we would say that the whole set of real numbers, and then there's a lot of ways to represent that, but for our context, we want to use something called interval notation. And with interval notation, you simply, it looks like a set of ordered pairs, but it's an interval on the number line. If you remember, the number line's got a 0, it's got negative infinity down here and positive infinity up here. It represents all the real numbers. And with interval notation, we just say, hey, this range of numbers can extend from negative infinity all the way to infinity. And with the infinity signs, we always use the parentheses because infinity is an idea. There's another symbol we can use if we want to include the number here. And we may get to that here in a second. But this is interval notation. It means basically a range of numbers that extend from negative infinity to infinity. Okay, let's look at this next equation. With this next equation, there are some real numbers that it's not that we can't compute them, it's just that the answer that we would compute is not a real number. Okay, we might get some form of imaginary number. Okay, so for that reason, this range is restricted. It's okay for x to be 0 because we can calculate the square root of 0. It's just 0. What we can't calculate is square roots of negative numbers. So in this case, our interval notation would look something like this. We would use the bracket to show that we're actually including the 0 in the domain, because 0 is okay. And we would say everything from 0 on to positive infinity. And this would represent our domain. Okay, so 0 is okay. And anything to the right of 0 on to infinity is going to be just fine. We just don't want any negative numbers, and that's because of the square root sign. The other thing that could cause a problem with domain issues is when we're dividing and we have the variable in the denominator. In fact, this situation with the square root and this situation with dividing where the variable may be in the denominator, those are really the only two things you're going to need to look out for that might prevent your domain from simply being everything. In this case, for the most part, any real number here works just fine, except 0. We can't divide by 0. It comes undefined, right? It's not even like it gives us an imaginary number. We don't have a definition for that. So we can't divide by 0. So in this case, we want to exclude 0 from the set. In other words, all real numbers except 0. Now, the interval notation starts to get a little messy when you're just excluding a few numbers, and which is why I tend to prefer some of the other methods of showing the domain. But it's okay. It's not a bad notation. So here's what it looks like. We're going to start at negative infinity because it's okay, right? We're going to go all the way up to 0. But we're not going to include it. So this parenthesis says we're actually excluding the 0. Okay? Now, if we stopped here, then we'd only have half the numbers that are part of the domain, right? We want the numbers on the other half of 0. So what we do is we use it's called a conjunctive operator. And it really just means that we're going to combine it with another set that starts just past 0, because we're not going to include 0, and goes on to positive infinity. And there, this basically says everything but exclude this 0. Just skip over it when you get there. Okay? Now, let's look at some that may be a little more complex. So this is very similar. We got the square root. We know that what's inside the radical can't be less than 0. Okay? So the way we deal with that is just solve the inequality like you've done and possibly in previous math classes. And so we say 2x plus 3 must always be greater than or equal to 0. Okay? And now we solve this inequality for x, and it tells us the values of x that would be okay in the domain. So we're going to subtract the 3. We're going to divide by 2. And we find out that x must always be greater than or equal to negative 3 over 2. Negative 3 over 2 is what would make this 0. Okay? And that's okay. So it's included. We have the equal sign there. So in this case, rather than simply being 0 to infinity, we can actually go down to negative 3 over 2, negative 1.5, and that's okay. So what we're going to do is we're going to include negative 3 over 2 on the left, and then we're free to go on to infinity because x's can be greater than this value. And there we have all values from negative 3 over 2 to infinity, and they're all just fine. Okay, last example. Here we're dividing. We've got an x in the denominator. We know that that can potentially cause an issue. So if there is a value of x that would make this denominator equal to 0, we need to exclude it just like we excluded 0 up here. So we simply solve the equation. We ask ourselves, well, what value of x could I put in here that would make this denominator equal to 0? Because I don't want that to happen. So I'm going to add the 3. In this case, I get x equals 3 over 2. So whatever I do, I want to make sure that x is not 3 over 2. I'm going to basically do the same thing I did up here, except instead of 0, I'm going to use this 3 over 2. So I'm going to start at negative infinity, go to 3 over 2, and exclude it, and then combine it with another set that starts just past 3 over 2, because I'm excluding it, and going on to positive infinity. So, recap real quickly. When you're considering the domain of a function, I usually tell my students, start off thinking that everything's good. You're going to have everything in there, okay? Because a lot of equations, they don't have problems. The two things you need to be looking for, radicals, especially radicals with even roots like square roots and fourth roots. And then you want to be looking at any situation where you might have a denominator. And then you want to find out, well, is there any way that that denominator could be equal to 0? And if it can be made equal to 0, then you want to exclude that number from the domain.